So let's suppose that you're working with your coding agent and you already have accumulated 50k tokens of context. And then you send an additional 1k tokens for an additional query, an additional question that you send to it. So that adds a full context of 51,000 tokens. Are you charged full price for those 51,000 tokens in your coding agent? The answer is most likely not if your agent harness is actually done correctly. But if it's not, then you're going to be paying full price for the whole thing, which is going to be very expensive. In today's video, we're going to be talking about prompt caching and how you can save a lot of money when using it correctly and implementing it in your agent harness. Okay, so let's get right into it. Okay, so let's start off the whole thing by saying, just clearing some misconceptions or some common errors when you think about prompt caching. If you work with software, you're probably already familiar with how caching works, and you probably expect it to be something like this. So something that happens, so for example, when you cache database requests. So let's suppose that you have your tiny user right here or your application right here, and it sends a query to your database. Right here is your database. And then the database, when responding, it returns the results to a cache. And then from the cache, it's going to go back to the user. And then whenever the user or your application sends the same query back to the database, instead of going all the way to the database and reprocess it, it's going to go to your cache. And this one is going to return it to the user without having to process it again in the database. That is how you would usually expect caching to work. And if you see it like this, you would probably expect prompt caching to work something like this. Maybe you have a message right here that is sent to your LLM, then, or not a message, let's call it a prompt. You have a prompt that is sent to the LLM. The LLM gives you a response, puts it in the cache, and then the cache back to the user. And then when the user sends the same prompt again, it's going to go straight to the cache and back to the user. That is completely wrong. This is a misconception, and this is not how prompt caching is. This is caching the outputs, and you cannot really cache the outputs in, I mean, you could technically, but it doesn't really, it's not useful for anything, caching the outputs of an LLM. What is going to happen is that we're going to cache the inputs, okay? So in a long conversation with your agent, let's suppose that you're already mid-conversation and you are 50k tokens in. And in this 50k tokens, you have already some tools, some messages, some tool results, etc. And then you ask another question to your agent, right? Then right here, this is going to be, let's say that you write a very long new prompt and it's another 1k tokens. So now you have 51k tokens. In order for your agent to have full understanding of the context of your conversation and what you're talking about, you have to send the full 51k tokens to the LLM. And then the LLM is going to respond to you with probably another 3k tokens. And then in order to ask another question, you're going to send another 1k tokens. And this time it is the whole 55k tokens that are going to be sent to the LLM on this time, okay? So as you can see, we are sending the same tokens multiple times to the LLM over and over, but we are appending a little bit at the end every single time, and that is how agents work. You append the next part of the conversation and you resend the entire transcript. Now, of course, there are some APIs that abstract this away. So for example, Responses API makes it look like the LLM remembers what it said before, but what's actually happening behind the scenes is that the LLM is reprocessing the whole thing. It's just making it easier for you to not see what's going on. But in reality, the LLM has to reprocess the entire context on every single response that it sends to you. That is also what's, by the way, not a great idea to have huge contexts in coding sessions, because they can very easily become very expensive. So this is what happens. And the reality is that if you keep doing this a session of 50K tokens is not really 50K tokens that are spent in your LLM. It's going to be 50K plus 51K plus 54K plus 55K, and that can go exponentially very, very quickly if you are paying full time for these tokens. Okay, so if you're paying, for example, $4 a token on the OpenAI API, which is one of the most expensive ones, this is going to be very, very expensive. So what happens with pretty much any LLM API nowadays, you have a different price for the first time that the LLM sees a token, and another price which is much lower for the second, third, or all the subsequent times that the LLM sees exactly the same thing. But in order to be able to enable this cache, different providers work differently, and you need to make sure to always enable this because it's going to be very expensive if you don't do it. Let me show you the pricings. All right, so let's take a very quick look at OpenAI and Anthropic, for example, which are some of the most expensive inference providers in the market. We have that, for example, GPT 5.6 Sol and Claude Opus 5. I think that their input price is about $4 per million tokens, and that is a lot. If you're doing that, what we mentioned before, sending 51K and 55K, and then all of like about more than 50K tokens on every turn, it's going to become very crazy expensive. So what's going to happen is that they're going to charge you a little bit more for the first time that your model sees the prompts that you're sending, and then next time it reads the same thing, it's going to route that processing to the same machine that did the processing before. And that way, it will hit the cache and it will only charge you 10% of that price. Okay. So that can very quickly save you a lot of money, of course. And as you can see, this can be very, very beneficial. So for example, here in this example that you see right here, what I did is that I took a hypothetical scenario where we have a 200K token context session with a given agent. Okay. And I simulated what that would cost you on Claude Opus 5, GPT 5.6 Sol, Gemini 3.1, Kimi, Grok, and DeepSeek V4. Okay, and the red parts right here are the full price that you would pay for that very small 200K token session without caching. And as you can see, both for Opus and GPT Sol, it would be ridiculously expensive at $41 just for a 200K token session, which is not a lot. This would be a short session. And same thing for Google and Kimi. All of this would still be quite expensive. But if you enable cache, you can see that this decreases dramatically. And DeepSeek is just on another level. It's just crazy how affordable it is right now. I think they're going to be raising the prices soon, but it's ridiculously, it's just basically free. And here's another plot that I have right here, which I wanted to show you. So for example, here you have the price per session. Okay, so on the x-axis you have the number of tokens that you have in the session. So as your session grows, if you don't use prompt caching, this thing is going to go, the price is going to go exponentially up as your session context grows. And if you enable caching, as you can see, it stays relatively linear, which is of course what you want. You want to grab as much of that 10% price as possible. And in order to do that, it is very important to pay attention to the models and to the providers that you're using, because different providers have different prompt caching systems. For example, on providers that use the Responses API, it usually is enabled by default because they do most of these things behind the scenes. But if you're using a Chat Completions API, it's not always by default, okay? So you need to take a look at how to do that. Let's now take a very quick look at some good practices to make sure that you design your agent with the best support for prompt caching. So just to show you something that is absolutely ridiculous, here in Tao, I have already enabled prompt caching for pretty much all the providers that are available right here. In this case, I am using DeepSeek V4 Flash over Hugging Face inference providers. And as you can see right here in the sidebar, we have the cache hit for the latest request and the cache hit in the entire session. So how much you have hit the cache. So here, as you can see, we have exchanged 10.9 million tokens with the LLM, okay? We have only 126K context window, but of course, since that goes back and forth, remember, on every turn, we have exchanged 10.9 million tokens, which is just ridiculous. And that has costed me 6 cents. That is, I have no words. Like, this is literally basically free. And what we have in Tao is that when you export your session, you can take a look at the exported material right here. So let me just open the session like this. It exports it in HTML. And you have, of course, your transcript, just like in Pi. Remember that Tao is a Python port of Pi. And the idea is to help you use this and understand how coding agents work. That's precisely why I have added these things right here. And this is one of the slight deviations from the Pi, from what Pi has by default. Pi does not have this cache window right here, this cache tab in the export. And here you can see your input cache hit. So here, for example, in the blue line right here is the cache hits, and the red one is the fresh, or the writes are not correctly measured actually. So these ones are actually the writes. So as you can see here, when we start the session, we start and the session starts off, and we're just charging full price for the tokens because we're just starting the session. But then as the session starts to grow, we are rereading the same tokens over and over and over, and then we start hitting the cache more often. And something important to keep in mind is that the cache expires after a few minutes sometimes, or after 30 minutes, etc. It depends on which provider you're using. On Hugging Face inference providers, it also depends on which provider your request is routed to. If it's routed to Together AI, to Cerebras, etc., that will depend on each provider. But it's usually pretty good time that you have available before it expires. On OpenAI, for example, it is 1 hour of cache on the OAuth API. On Anthropic, it is 5 minutes by default, if I remember correctly, on the API, and 1 hour if you're authenticated with Claude Code, etc. But as you can see here, it was full cache, and then right here is where I went for lunch. So right here, my cache expired, so it just wrote the cache again, and then went on after it was written for a few for a longer time. And then I just went for dinner, and then it expired again, and then I continued my session, and it continued with a fresh cache. And this is important because at this points right here, I had to pay full price for the tokens, and then after this, whichever tokens were reread, I paid them at a discount price. And as you remember, if you saw in the previous chart, this is the best way to save on long sessions. So that is the first thing that you want to keep in mind when you're using prompt caching. What is the expiration time of your inference provider? And on Hugging Face, actually, I have implemented right here in Tao really good support for prompt caching on Hugging Face inference providers. You should not miss any cache actually, because in Tao, all your requests are going to be routed to the same provider every single time, and it's going to hit a warm cache. Okay, so that's the first thing, the cache expiry. Another thing that you probably want to take a look is at whether or not your provider caches your prompt automatically. So for example, OpenAI and Hugging Face inference providers cache your input automatically, but other providers, so for example, Anthropic or Gemini, do not cache your input automatically. So you're going to have to take a look at that and enable it in your agent when you make the API calls. And something else that you're going to want to take a look at is dynamic system prompts. And that is very, very, very important to remember not to mess it up. Because let's suppose that you have your system prompt right here, okay? And then after that, you have a few messages, a few more messages, then another tool call, etc. And then your system prompt might be 10K tokens, which is a very long system prompt, but whatever. And let's suppose that you're going to be sending the whole thing over a conversation, and then at some point it grows all the way to over 200K tokens. You of course want on every single request, these tokens are going to be cached, right? Well, if at some point your system prompt contains something like, for example, a timestamp, okay? So a timestamp. So if you're changing in your system prompt the current time that you're telling to your agent, that is going to change something in your system prompt, and that is going to invalidate the entire cache after that. So you do not want dynamic things in your system prompt, such as timestamps, current working directories, which might change as well mid-session. All those things, do not add them to your system prompt if you do not want to make your sessions crazy expensive. And something else that of course invalidates your cache is if you run compaction. So let's say that you compact the whole thing and you turn it into a small summary right here, into a small summary, and then continue your conversation. This part right here will invalidate your cache because you will have, of course, turned all of this into a small summary, which is okay. I mean, that's exactly how compaction is supposed to work, so there is no real problem here. Just consider that that will reset your cache, okay? And there you go. Those are some things that you need to take care of and to pay attention to when you're building coding agents and in general agent harnesses, because you're going to be sending your conversation over and over to your LLM and you do not want this to be very expensive. So as a summary, remember that system prompts and your thread and your history does not have to change dynamically over the course of your conversation. You should not add anything dynamically to your system prompt, such as timestamps, current working directory, tool lists that are dynamically updated. Your history of your conversation should be append only, also to make sure to not make small mistakes and then invalidate your cache. Pay attention also to the expiry time of your cache for your particular provider. And lastly, use an agent harness. If you're not building your own agent harness, use an agent harness that allows you to also monitor cache hit rate. So for example, right here, I'm using Pi, and as you can see right here, you see CH, that is the cache hit rate for this particular provider. In this case, I'm using Kimi K3. And if you're using Tau, you have it right here on the right. You have the total usage and you have the cache hit on the last request and the cache hit in this session. And of course, in Tau, if you want to see the whole thing, you can always just export it and you will have this nice little cache hit report. Okay. Well, that's it for today. Thanks a lot for watching. I hope that this was educational and I'll see you in the next one.